In this video, we're going to have a look at the levelling question on the January 2018 Highways and Surveying 1 paper. On a new construction site, it's been necessary to establish a number of temporary benchmarks so that works can be controlled vertically. The table below shows observations during this levelling exercise which started and finished at the same ordnance benchmark OBM1. You can see all the details here. So we've got our back sites and we've got our foresights to various different TBMs. As suggested before, we've got two reduced levels, both starting and finishing at the same point. So this denotes that it's actually a closed loop circuit. Also, you can see that we've got the readings that have been taken to each temporary benchmark. You are required to draw up a levelling booking sheet and work out the reduced levels using the rise and fall method and show any corrections that are deemed necessary. You can see we have a typical levelling booking sheet. It comprises of a back site column, an intermediate site column, which we won't be needing today, a foresight column, and also a column for either height of collimation or rise and fall calculations. Last two columns are for the reduced levels and also the stations that have been measured. It's good practice to start the booking sheet with your stations, starting with OBM1, listing the temporary benchmarks, and finally back onto the OBM1 station. We know from the question that the reduced level of OBM1 is actually 66.750 metres above ordnance datum, and we can put this in to start with. Notice how I leave the last OBM1 reduced level blank, because we're finally going to use this as a double check. From the question itself, we can now input all of the back site data and the foresight data in the relevant columns and rows. Here we have a back site reading onto OBM1, followed by a foresight reading onto TBMA. Then we have a back site reading onto TBMA, and then following on to a foresight reading onto TBMB, and so on and so forth. The next procedure is to sum up the back sites and then sum up the foresights. We can find any misclosure by the sum of the back sites minus the sum of the foresights. As you can see from this example, we have a misclosure of 0.006 of a metre, or 6 millimetres. The next procedure is to adjust the sum of the back sites so that they equal the sum of the foresights. We have 6 back site readings. Conveniently, we have a 6 millimetre error in this question, and therefore 1 millimetre from each of the backsite readings will be subtracted and shown as in the video. We are now in a position to start calculating our rise and falls and ultimately the reduced levels of each of the stations. Using the rise and fall method specified in the question, we can simply take our backsite reading minus our foresight reading to get either a plus or a minus figure for our rise and falls. You can see from this example, initially we have a large fall because it's a minus figure. The second is a very slight fall. And the third is just over half a metre. Once we finish doing these, we can actually do a double check. And we can actually sum up all of these rise and falls. Because it's a closed loop circuit, they should equal 0. Then we are in a position to calculate each reduced level, taking our first reduced level and either adding or subtracting our rise and fall. Because it's a closed loop circuit, we should find that the two OBM1 stations, in the same station, should actually have the same reduced level as to begin with, the 66.750 meters. And this is another check that needs to be displayed, i.e. your last reduced level minus your first reduced level, in this instance, should equal 0 meters.